Hey guys, I'm Aaron with Aleeknives. Welcome to my shop. This is episode 3 of the Revolution Grinder build series. In this episode, we're going to stick it together. We're finally here, we're going to weld it all together. In episode 1, I showed you what comes with the kit. In episode 2, we prepped all of the parts, we did our layout lines, and we drilled all our holes and tapped all of the holes that needed to be tapped and shaped our parts. This is episode 3, where we're actually going to dive in and create the grinder. At the end of this episode, we'll have a piece of functional art. All of our parts are ready for welding. I've gone ahead, got everything ready, and then I cleaned it all off with acetone. You'll see there's no more blue dichrome on any of these parts. They're all nice and clean and ready for weld up. So we're going to start by building the main body with our receiver tubes. So you're going to want to make sure that you orient these with the 2 holes up, so that your screws can go up and towards the front. So we'll go ahead and start to weld this together first. We'll push all this stuff off to the side and we'll just get started. So let's talk a little bit about welding. You're going to see me throw tack welds all over this machine, and there's a very specific reason that I'm doing that. When you weld metal, it shrinks. That's all there is to it. You do a hot weld, it's going to shrink as that weld cools. Basically, if you do a weld on one side and it shrinks, it's going to open up the other side. Therefore, when you're doing a project like this, you want to move around the machine, putting tack welds in place to hold the structure together before you do any hot bead welds. Now you'll see, now I've done all 6 tacks all the way around, which is going to hold it together. Now I'm going to solidify the weld by doing a nice hot bead, create myself a nice hot puddle, and then I'll do circles to drag that puddle for about 1 inch. I'm going to do about 1 inch long hot bead, 2 places on this side, and then I'll flip it over and I'll do the exact same thing on the other side. That's more than enough welding to hold this bad boy together. Moving on to the tracking arm pillar. This is the spring tab. I looked at this for a while before I decided to just hold it in place with my thumb. Now you do want this alignment to match up right there with that 60-degree angle that we cut at the bottom of the tube. That's purely for aesthetics, but it does look better if it's at that same angle. It'll work even if it isn't. I held it in place with my thumb. That seemed to be the easiest way to do it. I tack welded it, I made sure it was right, and then I solidified that weld on the other side. Now I've got it on the main body here. I've pushed it forward about 1/4 inch from the back of the body. And once again, I'm going to throw a couple tacks on this side. I'll flip it over. One thing to make sure is, you'll see when I flip it over, I push it down against the table to make sure that those tack welds I just put in don't protrude outside of the valley that I put them in. If they protruded, then I wouldn't be able to clamp this down to be flat on the table surface, which I wanted to do. If those tacks would have protruded, I would have needed to clean off the tips of the tacks to where everything could lay flat so I could clamp it down for my tacks on this side. Now that it's nice and solid and flat, clamped down in place, I'll go ahead and throw my 2 tacks on this side. Now I'm able to solidify this weld joint with a nice little hot weld also. You'll see I'll clean it up here with a hot weld, just a short 3/4 inch weld on both sides. You probably don't even need this weld. The tack welds are probably plenty strong enough to hold that together. This is purely personal preference right here. If I could have to do over again, I probably would have, after I tack welded everything, just ran a nice consistent bead all the way from the front to the back. I think that would have been more aesthetically pleasing for me on my machine. Now it's kind of a little difficult to go back and to run, a short piece of weld on the front and back to make it look like a nice, neat weld, I guess. Not a big deal, personal preference. Let's flip this bad boy over. Same deal here. I've got the wire brush and I'm using the file. The wire brush, if you have any weld splatter that jumps off, from your shielding gas or whatnot, you scrape that off with the wire brush and then you use your file to clean things up just to make sure everything's nice and flat. Now this is the main body that holds the motor. You can put this on however you want to. I decided to line it up with the bottom of the curve on the top tube. So just from the back to the front, I lined it up. I made sure that it was nice and even across the front. I measured this, I looked at this, I eyeballed this, I made sure that it was right more than once because these plug welds would be very difficult to get out. It's one thing to grind off a tack weld, but a plug weld, you would have to drill a hole larger than the plug to get these out. So make sure you have it right, clamp it down so that your parts don't move during this process, and then you can go ahead and do a nice deep plug weld to stick this to your main body. I went ahead and did 2 plug welds in this initial phase. I believe that that's plenty strong enough to put it together to make sure that the machine operates. And then after we're absolutely positive that everything's operating flawlessly and tracking the way we want it, we got all of our pieces tacked together, then we're going to go back and we'll take it all back apart. We'll solidify all of our weld joints. We'll finish up plugging up all these other holes. And that's just kind of part of the whole build process. The fabrication process goes like that. You want to put it together and make sure it works before you really go all out. Now we're moving into probably what's the most important part of building this machine. These upright tubes here have to be pretty much perfect for this machine to operate. So you can see I've used some 90-degree magnets to hold them upright. And then what I did that I didn't show you is that I measured the distance of the inside of the tubes at the base and made sure that the distance was the same at the top of these uprights. Then I went ahead and put the axle through just to kind of make sure that I didn't have any binding. The way you're going to want to do your welds here is very similar to how you change a spare tire. You want to alternate the lug pattern on a tire, same exact thing here. So, which means that you're going to want to put a weld on the left and then put a weld on the right. Put a weld on the left and then put a weld on the right, working your way around these tubes. That way, if you have any weld shrinkage, by moving from one side to the other, you're offsetting that shrinkage. And you'll see that this method works out really well. When I'm done here, the axle bolt moves absolutely flawlessly with no friction and no binding. I do eventually go back and solidify these welds with a nice hot bead across both sides. Actually, not both sides, or all the way around these, because I feel like these uprights, they hold the entire machine. There you go. You can see that that's perfectly freed up and that the axle can move in and out. I was just kind of checking in the middle, before I get really crazy on throwing these tack welds down. I'll tell you, having the MIG welder is a game changer over a stick welder, but it is good to learn how to stick weld before you move into a MIG welder. The stick welder does teach you a lot of things. There we go. It's nice and free. We're going to move on to doing the cam lobe assembly next. This is absolutely critical that you get right. The order in which these lobes and spacers go on have to be right. You do a lobe, a spacer, then you put it through your first upright, then you do a spacer and a lobe, and then another lobe and a spacer. You push it through and you do a last spacer and a lobe. And the thing is these lobes are not symmetrical, so it matters which direction you have those on. Just like that. I had it on backwards and I caught it, so I flipped it around. Now I'm just going to go ahead and throw the nut on. I'll tighten this down just slightly to make sure that I don't pull those tubes together before I weld this. Now I'll move the whole assembly over to my upright, and I'm going to teach you a couple tricks on how to keep everything straight. Alright, so I've taken my base with my cam lobes, and I've laid it on my main body. I spaced it off of the round portion of the main body tube, so the cam lobe comes right off the main body. Couple things to take note here. You definitely want to make sure that this is straight, so that when it pivots, it doesn't pivot wonky. So you can use this front edge or the back edge, make sure that everything's straight. Number 2, you want these cam lobes to be straight up and down. You don't want them to be kicked in or kicked out. So if you decide to clamp these like I did, you need to make sure that you put even clamping pressure directly on either side of the axle bolt. If you go down low below the axle, it's going to cause these ears to kick out. And if you go above the axle, it's going to cause them to kick in. So you really want to be in line with the axle. I'm a little bit low on this one, so I'm going to raise it up. But you want to be in line with the axle, measure the distance here, and then measure the distance here. What could possibly happen if these lobes are facing in, when you try to rotate it, these lobes are going to scrape the tube and it's going to cause friction, unneeded friction. And you want this to move freely. So it's really important when you get these set up to clamp them in place, dial it in. Don't clamp them too tight because you don't want to cause friction against this tube here. So just lightly clamp them to hold them in place. And then what I'm going to do is I'm going to tack it here, tack it on the bottom. I'll see how these are free. I'll clamp this up, make sure it's right. I'll tack it in all 4 places. Make sure the machine works by pivoting it. Once I'm happy with it, I'll go ahead and put a little more sufficient welding in place. Now that we've got everything completely lined up, let's go ahead and tack this bad boy together. Throw a nice hot bead on the top of each cam lobe, and then I'll move around the back side, and we'll throw a hot bead on each one of those too. After I'm done with this set, I'll move directly over to the set on the back, I'll clamp those up, and I'll do the exact same procedure. There we go. Now this next thing I'm going to show you with these knobs, this is really cool. You install a nut in your vise, and you lay a washer on top of the nut, and you screw your bolt down, and what happens is that creates a shelf for the knob to sit on to do this plug weld. You'll see, I'm going to pull this bolt out and I'll put a new bolt in and you'll see exactly what I'm talking about. Once I install the bolt and screw it all the way down, when I put the handle on the top of it, you'll see that if I screw it down farther, it increases the gap for the plug weld, and if I were to unscrew it, it would decrease the gap in the plug weld. And you want to give yourself about an 1/8 inch room for the plug weld. So here you go. See, when you screw it in, it increases your gap. Pretty cool. Brian's the one who showed me how to do that. I thought it was genius, so I thought I'd make sure to point it out. It is really interesting how when I do a weld, my camera zooms in and zooms out and zooms in and zooms out. That is something that I learned, unfortunately, after I did the entire filming sequence. The next project that I do where I'm doing any welding, I will lock off the autofocus feature before I do the footage. Hopefully that doesn't bother you guys too much. Okay guys, I'm with Brian. I think this might be the coolest part of the build is when you stand it up for the first time. So let's do it. This is getting pretty heavy. Oh, check that out. Oh yeah, pivots nice and easy, like it's made to. Love that. Look at that. Wow. Now, I will tell you, just if you put it down and it doesn't sit at 90 degrees, you can remove a little metal off the tube. And if you put it up and it goes past 90 degrees, you can weld a bracket here with a nut to limit the travel of this. And then if it doesn't hit 90 degrees, you can remove a little bit of material off these top tubes. So this is fully adjustable. That's looking good. I'm digging it. I'm really digging that. Okay. Everything's looking really nice. I am going to start doing my finish welds. Basically, at this point, I need to finish these plugs out, which I don't think I'm going to do all those plugs. That seems like a lot of plugs. I'll go here and I'll go there and call it good. I'm going to leave these 4 open. Well, I don't know. Maybe, no, I won't. I'm going to go ahead and plug them up. Why not? And then, let's see. I'm going to put a little more welds on each one of these ears. And that's really it for the welding, I think. Until we get to the table and stuff like that. But, and there's some other little pieces that need to be welded. But as far as this goes, I think we're good. So, cool. Right now, I plug welded these and I ground them smooth. These are rough and all the edges are super sharp. I have not gone through. I just wanted to get everything welded and put together to check for fitment at this stage. Now I will take the whole machine apart and I will clean up all these edges and round them over so that they're comfortable in your hand to operate. Every hard edge on this machine will be cleaned off, smoothed out, ground, and finished when I'm done. This is the fitment portion where I just wanted to make sure that everything was right. Everything's good on this machine, so now I'll get to go ahead and take it apart. You can see actually when I figured out that this was rotating properly, I went ahead and solidified these welds right here and right here. And on the back side, you can't put weld on the inside because it'll interfere with your column posts. But you can weld these tabs on the outside of the tabs and it won't interfere. Do you see what I'm saying? If you put a weld strip here, when you rotate it, the weld strip will interfere with this top portion of the column. So to go ahead and finish these up, you're going to want to weld on the outsides of these tubes or these ears to make sure that you're not going to cause any friction interference there. Overall, I think this came out really, really, really nice. Back out of there. All right, I'm not going to show you guys how to do any of the wiring because I'm not an electrician. But here we go. Start. And then crank it up. Tracks perfectly. Everything's working absolutely flawless. So I took all the parts and I put them together. And now we have a Revolution grinder. So cool. Now, granted, this is all tacked and everything is dirty right now. I will take this machine apart, again, finish weld, clean all my welds, clean all my surfaces, clean it up, attach my handle. I don't have my handle attached yet, but I wanted to turn it on, make sure that it runs, that everything tracks properly, and that the machine is what I want it to be, both horizontal and vertical. This machine is awesome. I absolutely love it. This is why I fell in love with this machine. So you're running like this. You've got a nice wide platen. If you're using a jig or something, this platen's big enough for you to use a grinding jig on it. Then you can flip it sideways. And what is really neat about this is you can loosen this arm right here and you can pull it out. So basically, you're going to pull your work rest out right here. Okay. Then you pull this arm out and adjust it this direction and insert your work rest this way. How cool is that? So now you have a platen on your horizontal. It's pretty neat stuff if you ask me. And it's all adjustable. The other thing that's really cool about this grinder that I'll show you that I liked a lot, in the vertical mode, actually you could run it like that in this mode too, but in the vertical mode, like this, whoops, I got this. On this work rest, you've got two bolts here, and this allows this to pivot up and down. That's what I actually wanted to show you, which is a pretty neat feature. So basically, since this holder right here pivots up and down, it allows you to take your work rest and angle it like this, all the way to a nice angle, so you can do all kinds of neat grinds and things with handle materials. And this is a very versatile grinder. It allows you to do a lot of different things with it. Super cool. In the next video, I'm going to take this grinder and show you how to really elevate it. You could use this grinder just like this right now. You could put this thing to work today in your shop. But you're building it, so take the extra time to make a really good product. That's the thing. You get all the parts to make a grinder, and you decide what level of grinder that you end up with after your build. This is a grinder. It functions perfectly, but I'm going to elevate the entire grinder by what I'm going to do in the next video. I plan to take this entire grinder apart, finish weld all my seams, lock everything in. I'm going to grind off all the hard edges. I'm going to do surface conditioning over the entire grinder and some finishing touches. I'm going to finish out my handle. There's several things that I'm going to do in the next video. I don't want to tell you all of them because it might discourage you from watching it, but it'll be a good video. So catch me on the next one. In the meantime, this is part 3 of the Revolution grinder build, which means part 1 and part 2, if you haven't seen them yet, they're valuable videos to go and watch also. I'll put links right here for the whole series. Thanks for watching, guys.